m and n. See, previously it was in terms of z. Okay, I'm just see if I'm just changing this expression. So here we can see that dou m by dou y with x and dou n by dou x with y is equal to dou square z by dou x by dou y, because I am doing the second derivative. Okay, I'm doing in a this is the second derivative. This is the first. This is the differential equation. Then dou z is the first derivative. Then afterwards here I am getting the second derivative form. Okay. So thus differential dz. So whatever this dz is there, I can finally write it as this expression as m. Whatever this expression is there, I am putting this m here in the sixth equation. So m dx plus this expression I am writing as n, and this I am putting here in sixth equation n dy. So whatever this expression is there, it is nothing but exact. Here we are saying that this equation is an exact differential equation. Why we say that? Exact is nothing but means state function nor path function. It's a exact is nothing but it is a state function. It is not a path function. Okay. So do you just remember this? Exact differential is nothing but, or exact is nothing but, it is a state function. ఒకటి గుర్తుపెట్టుకోండి, పాత్ ఇంకేమని గుర్తుపెట్టుకోకండి, ఇట్స్ ఏ స్టేట్ ఫంక్షన్. సో ఫైనల్ స్టేట్ ఫంక్షన్ మీన్స్ finally that is nothing but whatever this dou m by dou y is there, it is equal to dou n by dou x with y. So this in this form, if any expression is comes, this is nothing but it is a state function. You can just look out this equation also. I'm just holding this page few seconds. Can I move? Can I move forward? Yes? Yes. Well, we'll take one more example, how the relation between the properties x, y, z changes. So here, as I said that y is here I'm taking as y equal to x comma z. So here we can say that x and z are independent properties and y is the dependent property. But here y and x are the mathematical expression we are doing. So here I am using the term as variable. If I am taking in a thermodynamic way, then I should write it as dependent properties. Okay, now we are just writing as we are doing in a mathematical expression, so that's why I'm just using as dependent variable. So previously how we have derived the equation 6, in the same way I have written this equation 7. Yes, can any one student? Are you there? So if you just take the equation 6 and 7 combined together, means the previous equation and this equation, then few of the terms will be eliminated. So finally you will get this expression like this. So equation 6 and equation y, if I just combine together, I will get this expression. మీరు పేపర్ పెన్ మీద రాస్తే మీకు తెలుస్తుంది. So what I have done is combining the equation I have done, that is you can see here. So then afterwards what I did is that whatever the z terms are, I'm getting this, I'm moving to LHS, and that x terms I'm moving to the RHS, so that I will get a finally simplified expression like this: dz on the left side and dx on the right side. So since I am saying that x and z are independent variables, the terms in brackets in the above equation must be 0. Okay. Since we are saying that x and z are independent variables, then whatever the terms which are holding with x and z, that becomes 0. So finally we'll get the expression like this: dou z by dou x y of dx. Okay. So finally, just students, just note down this expression. This expression is carried forward to the next page. So this is my eighth equation. So you can see this 1 minus dou z at ఏదైతే ఉందో అది నేను నెక్స్ట్ పేజ్ మూవ్ చేస్తే ఐఎమ్ రైటింగ్ as dou z by dou x equal to 1 by dou y by dou z. ఇక్కడ మనకి కొన్ని టర్మ్స్ క్యాన్సిల్ అయిపోతాయి ఇక్కడ. Dou z by dou x, if I write dou z by dou y with respect to x, if I am doing, then what happens? I'll get it as 1 by dou y dou zx. So that I'm writing as, so దీన్ని మళ్ళీ ఇంకా సింప్లిఫై చేస్తే ఈ విధంగా వస్తుంది ఇక్కడ. This expression I'll get this one. So using the equation 8, we will get it as dou z by dou x y equal to 1 by minus this equation. Finally we'll get this equation, that is dou z by dou x with respect to y equal to, so if I'm just putting this equation, whatever these multiplication equations are there, this will go to the numerator and this will go to the denominator. That's it. I'm more making simplification. Whatever this numerator is there, I'm pushing this numerator value into the LHS left hand side. So that is nothing but dou z by dou xy and dou y by dou z, when it is moved to the LHS, equal to minus dou y by dou xz. So finally, if I move this expression also to LHS, finally I will get it as this equation. On rearranging the expression, I'll get it as dou x by dou y with respect to z, dou y by dou z x, dou z by dou x y equal to minus 1. So this type of equation which you are getting, that is equal to minus 1. See here you can see dou x, dou y, dou z. And these are depends on z, x, y equal to minus 1, then that is called cyclic relation. ఇక్కడ మీరు cyclic గా మూవ్ అవుతుంది చూడండి, x by y, then y by z, then z by x. It's moving in a cyclic way. ఇలా సైన్స్ ఆర్డర్లో ఇట్లా cyclic గా మూవ్ అవుతుంది. So you can see x by y, then afterwards y by z, then z by x. Again it comes x by y, so it moves like this, okay, cyclic. So that's why it's named as cyclic relation, which is equal to minus 1. Now one problem, if you just take down, please you can just take this screenshot or this whatever you can you can have. So the problem is, show that the differential change in function when the state of the system changes from x, y, z to x plus dx, y plus dy, z plus dz. Okay. So what they are asking is that suppose x, y, z are the variables are there. So what they are saying that when the system is changing, the change is taking place, that is x plus dx. Y is taking place, the change in the system is taking place with y plus dy. Z is taking place with the change z plus dz. So what happens? When these changes are occurring in a system? Okay, so the given data is also this expression they have given for this. So you can use in the represent it to show this one. So let us solve this problem 1. So consider function f. I'm taking one example as it's a continuous of the previous question. So f equal to x square y cube plus xz. So if I just differentiate with respect to yz, dou f by dou x, yz with respect to yz, then I'll get 2x y cube plus z. In the same way, dou f by dou y with respect to x and z, you will get this expression. In the same way, if you differentiate with dou f by dou z with respect to xy, you will get this x. Okay. So now we just add up all this, put all these things in this expression. Now look, already they have given expression like this. Okay, already given this expression. And now we have got the values. Dou f by dou x value we have got. Dou f by dou y, dou f by dou z values. We got these values. So just put these values in that expression. Right? So whatever these expressions we are getting here, put these expressions in whatever these values are there, put these values in this expression. And we know that f is a function of x cube, y cube plus xz. Okay. So what we'll do, what I will do means this, whatever this is there, df equal to, I'll just differentiate this f. So what will happen, dx square y cube plus dxz. So when I just differentiate this expression, so I will get it as 3x square y square dy plus 2x y cube dx plus x dz plus z dz. So this finally this expression I will get. Okay. Next. So let us take one more problem 2.